So we're going to talk about concentrations. Concentrations can be measured in a couple different ways. We're going to talk about three different ways that they can be measured. The first one we're going to talk about is percent concentration. So percent concentration is exactly that. It's expressed as a percent. The thing that we have to identify after a percent concentration is that what are we talking about here? So V over V is volume for volume. And so in the case where you get a volume for volume percentage, we're talking about something like this. So if you have 5 milliliters of a substance, and you've got that in 100 milliliters total, so the entire substance is 100 milliliters, then you're dealing with a 0.5% of volume for volume concentration. So you could say that it's 0.05 concentration. So another way to express a concentration using percentages is weight over volume. So if you see percent WV, so that would be something like if you put 3 grams of something in every 100 milliliters, well then it's 3% weight over volume. Because what we do, of course, is divide the numerator by the denominator, and then you're meant to times by 100. Now, in keeping with that, this here would also be 5% and not 0.5. Carrying on. Okay, so the concentration can also be expressed as a weight volume, and so the way that we do that, the way that we kind of show that in formula form is the mass of the solute over the volume of the solution times 100 equals your WD, and of course you can also do it weight over weight, so you don't have to just do it volume over volume, you do weight over weight. So the mass of the solute over the mass of the solution times 100 is going to represent weight for weight. Parts per million is a tricky one. It's normally used when we're describing really small amounts. I'm not sure if I'm correct in doing so, but I always equate it to sort of like an imperial measurement, because it's not one that we always like to use in chemistry, but it conveys a message. It really does show when something is really small. So a part per million is self-explanatory in that it is however many parts are in 1 million parts in comparison. So for example, 1 part per million could be a milligram per kilogram. So there you would have 1 part in every million. So a more explicit example of that is 1 gram for every 10 to the power 6 milliliters. So there you have 1 part per a million. So there's 2 others that you need to be aware of, and that's part per billion and part per trillion. And again, those are self-explanatory, so they're just saying that you have 1 part for every billion of the solvent, or 1 part for every trillion of the solvent. Amount concentrations, those are the ones that you will generally run into in chemistry, and those are the ones that you should familiarize yourself with the most. I mean, these always make good test questions to just say, hey, just show me you understand parts per million, or show me you understand percent concentration, because they do show up in a lot of different places, like when you're consuming produce or things like that, or you're consuming things in the grocery store. I mean, so anyhow, moving on. Amount concentrations are the most popular in chemistry, and that is in moles per liter. And so the general formula for amount concentrations is C, and in case you get confused, or in case you can't tell, this is not a capital C, it's a lowercase c. Capital C, I believe, is used as a constant in talking about energy in calorimetry normally. C is normally specific heat capacity, I think. Anyhow, it's a lowercase c, and C is equal to N over V, so a number of moles over volume. So there, we've got, here's an example. So if you had 0.186 moles over 0.250 liters, you would divide that number by this one, and you would end up with 0.744 moles for every liter. So you will be doing a lot of calculations with that.